So we can take a very, very important chapter in chemistry, which will be in your NEET paper. That is basic concepts of chemistry.
Okay.
Have you heard about a mole? Mole.
Yeah.
Okay. So in this chapter, we are taking the topic of mole concept.
Okay.
So you did chemistry in which year?
I did it last year, but it was like the basics, like atomic number,
Yeah.
finding neutrons, protons, stuff like that.
Yes. All right. Good. So that means next year you will be taking that advanced chemistry.
Mm-hmm.
So first we will do what is a mole. Mole is nothing but a group of a particular number of particles. So that particular number of particles are 6.02 into 10 raised to power 23 particles.
Okay.
So these particles is called a mole. You can have
Okay.
1 mole of element. 1 mole of element will have these many atoms. If you take
Okay.
1 mole of a compound, it will have these many molecules.
Okay.
Can you name 2-3 compounds?
Water,
Yes.
carbon dioxide,
Yes, that's right. One more.
fluorine,
One more compound. What is the formula of common salt?
Sorry?
Common salt.
Na?
NaCl. Sodium chloride. So yes, you are right. So 1 mole of a compound will have these many molecules. Even you can have 1 mole of ions. You can have 1 mole of electrons, protons, anything. It is just number. Like if we say what is dozen, we will say 12. If I ask you what is decade, decade means?
Gone. Like
Decade means 10 years.
Okay.
So mole can be taken in number of particles also, or mole can be taken in the amount of substance also.
Okay.
So an amount of substance containing these many particles. Actually, for convenience, we can write down this as Na also. Na. Na stands for Avogadro's number, Avogadro's constant. So this this whole of this number we can just show by this symbol Na. It is also called Avogadro's number. So if you take 1 mole of any element, it will have this Avogadro's number of atoms. 1 mole of compound will have number of molecules and so on. And also you can take in the amount of substance also in terms of mass also.
Okay.
As I told you, this moles can be related with elements also, with compounds also, with gases also. We can have moles of gases. So one by one, we will try to correlate. First is moles with elements. How many elements are known at present?
117.
18.
18.
Which we can see in the periodic table.
Okay.
So the arrangement of elements in the periodic table is according to increasing atomic numbers.
Mm-hmm.
All these 118 elements will have different atomic number. The symbol is Z. So it will be equal to what? Number of
protons.
Protons. That is right. If you take atomic mass, symbol is A. So you have your little brother?
Yeah.
Okay. So how old he is?
He's 7 years old.
Okay. So atomic mass will be number of protons plus neutrons. So if I give you A minus Z, it will give you what? Number of neutrons.
Okay.
And if the atom is neutral, the number of protons and electrons will be same, equal.
Sorry?
If you have neutral atom, the number of protons and number of electrons will be equal to each other, no? Not in the ion, but in neutral atom. Like suppose if I give you sodium, always atomic mass is written on top left hand side corner. Atomic number is written here.
Yeah.
Always. So if you take the exact value of atomic mass of sodium, that is 23. Atomic number is 11.
Okay.
So if I give you the question, how many electrons, how many protons, how many neutrons it have, and suppose it forms Na plus ion, Na plus. Na plus ion is formed by losing an electron, no? If
Yeah.
loses an electron, it becomes Na plus. After becoming this, how many electrons, protons, neutrons it will have? Find out both the questions
Okay.
in the atomic form.
That will be 23 protons.
No, bottom left hand side is atomic number. Atomic number is giving us number of protons. How
Yeah.
many protons it will have?
Oh, 11 protons.
Yeah.
And it will have 11 electrons. And then it will have 12 neutrons.
That is right. That is
And
right.
then for Na plus, it will have 10 electrons,
Yes.
11 protons, and 12
neutrons.
neutrons.
So you see that when any atom is forming an ion, only the electrons will get changed. Only the electrons are changing, making no difference to the number of protons and number of neutrons. They are still the same.
Yeah.
So we get a very, very important statement that when an atom forms an ion, then neither its atomic number nor its atomic mass will change. Neither its atomic number nor its atomic mass will change. Because number of protons are still the same. Atomic number is number of protons. So atomic number will not change. Atomic mass is number of protons plus neutrons. Protons plus neutrons were 23 before also, 23 after also. So Na plus was a cation. You know what is cation?
No.
Positively charged ion. Positively charged ion is called a cation. And if you take the negatively charged ion, that will be called anion. Anion will be produced by accepting electrons. Cation by losing electrons. Like suppose if you have fluorine, atomic number is 9, atomic mass 19. It forms F minus.
Okay.
So in both the cases, find out how many electrons, protons, neutrons. How many electrons, protons, neutrons?
Okay. For the first one, there's 9 electrons, 9 protons, 10 neutrons.
That is right.
And then over there, there's 8 electrons.
8?
10 electrons. And then 9 protons, 10 neutrons.
That is right. Because in this case, it is not losing an electron, it is gaining an electron. So if we take the relative charge of electron and proton relative to each other, -1 and +1. So when you have electron extra, 1 electron extra, that is why one negative is coming on the atom, 1 minus, na? Because 1 electron extra.
Okay.
F minus is called a anion. Anion is nothing but negatively charged ion.
Okay.
Okay, so we are doing this mole concept. All the different elements will have different atomic masses, and the reference for standard atomic mass reference is of carbon atom. So you can see basis of relative atomic mass scale. Something has to be standardized. So the basis is taken to be carbon atom, C12 atom, C12. Because carbon will show isotopes. Many elements show isotopes. Have you heard the word isotopes?
Sorry, breaking.
Isotopes.
Ma'am, you're breaking.
Acha,
Hello?
yes, my internet is all right. No problem
I
here.
can hear you now.
Now it is all right?
Yeah.
Okay. So
Yeah.
you have a very, very long name. Divya Shri Meenakshi Sundaram. Yeah. Okay. So you are called by a name Divya only, na?
Yeah.
Hmm. So isotopes.
Mm-hmm.
Isotopes will have different atomic masses and same atomic number. Atomic number is same, but atomic mass is different because of difference in the number of neutrons. If
Okay.
isotopes, they are atoms of same element with same atomic number but different atomic mass. So when atomic mass is different, which property must be different? It is due to difference in the number of
Neutron.
neutrons. So they will be different in neutrons. They are called isotopes.
Okay.
So that, and for isotopes, to find out the relative atomic mass, you have to take all the isotopes and then we take the weighted average of isotopic masses.
Okay.
Average has to be taken. And that is the reason that so many elements will have fractional atomic masses.
Okay.
Many elements. Like if you take hydrogen, it is not exactly 1, it is 1.008. Although
Yeah.
it has one electron, one proton, and no neutron, but still it is having this atomic mass. If you take chlorine, boron is 10.8, chlorine is 35.5, magnesium is 24.3.
Mm-hmm.
So if you take number of protons plus neutrons, they cannot be the fractional value. So we have to take the percentage abundance. Just see, this is a very important topic. If you take chlorine, atomic mass is 35.5. So there are two isotopes, 35 and 37. There are two isotopes.
Okay.
And if we find out the percentage abundance, that is found with the help of a mass spectrometer. Mass spectrometer, it was found that the percentage abundance of 35 isotope is 75%, and this is just 25%. So that means out of total chlorine, 3/4 is 35 isotope, 1/4 is 37.
Okay.
So to find out the relative atomic mass, you have to take the both the abundance. That means 75% of 35 plus 25% of 37. That is how the answer comes out to be 6.5. Like suppose
Okay.
I have taken 5 subjects. In 4 subjects, I have got very, very good marks. And I'm not getting very good marks in the fifth subject. But when I find out my average, then I will have to include that fifth subject also, na? Whether I
Yeah.
like it or not, I will have to include. So
Yeah.
here we have to include all the isotopes.
Okay.
So that is why so many elements will have fractional atomic masses. And
Okay.
atomic masses will be given to you. On the first page, you will be given the atomic masses, so there's no need of cramming them up. We don't have to cram up.
Okay.
So the basis is taken to be carbon. So atomic mass, one carbon atom, and we always take C12 isotope. So one C12 atom has a mass of 12 units. It can also be called atomic mass unit. AMU stands for atomic mass unit.
Okay.
But if you take 1 mole of carbon atoms, you will have a mass of 12 grams. So 12 grams will be the mass of how many carbon atoms? 1 mole.
One. Yeah.
How many atoms?
One.
1 mole.
6 point.
Yeah. So approximately you can take 6 also. 6
Okay.
into 10 raised to power 23 carbon atoms will weigh 12 grams.
Okay.
12 grams is not the mass of single atom. It will be
Okay.
mass of 1 mole of atoms.
Okay.
So on the basis of this statement, if I give you the question that find the mass of 1 carbon atom in grams.
Um. 1 carbon atom.
These many carbon atoms are weighing 12 grams.
Yeah.
Therefore, 1 carbon atom will weigh how much?
Tw- yeah. Uh, is it 6 times 10 to the power of 23 divided by 12?
You will just apply unitary method, which we do in maths. Na? If 5 apples are costing this much, then how much will 25 apples cost? So whichever thing you want to find out, that should be on right hand side, na? Right hand side. Like we wanted to find out the cost. So cost was coming on right hand side. So here you want to find out the mass. So mass you will take on the right hand side, and number of atoms should be on left.
Okay.
Statement that left hand side is atoms. So these many carbon atoms weigh
12.
12 grams.
Yeah.
Therefore, 1 carbon atom weighs how much? So it will be reverse thing, which you were telling na, it is reverse of that.
Okay. Okay.
It is 12 divided by 6 into 10 raised to power 23. So whenever you are confused, then just think of the statement in your mind and you will never make a mistake.
Okay.
So what is the answer on calculation?
Um. 2 times 10 to the power of 20. 23.
10 raised to power 23 is in the denominator. So when you bring this in the numerator, then
Negative 20.
yeah. And in India, in any paper, no calculators will be allowed.
Okay.
But calculations will not be very difficult. They will be quite simple. But still, you should be able to do this step, na?
Yeah.
So 2 into 10 raised to power negative 23 grams. That is the answer.
Yeah.
So any problem up till now?
No.
All different elements will have different atomic masses. And if the atomic masses are given, like suppose it is given to be 1, carbon is given to be 12, nitrogen is given to be 14, and oxygen is 16, and you are given sodium to be 23. So that means 1 mole of carbon will weigh 12 grams. 1 mole of nitrogen weighs 14 grams. 1 mole of oxygen will weigh 16 grams, and it will have 1 mole will have Avogadro's number of atoms also, na? 1 mole of sodium weighs 23 grams and contains Avogadro's number of atoms. Find the mass of 2 moles of sodium.
2 moles of sodium.
Hmm?
1 mole of sodium is 23
Grams.
So
Yes.
grams.
Yeah.
So 2 moles would be 46.
That is right.
Okay.
So just see you have understood the concept. So now there won't be any problem in doing any question. If you have 3 grams of carbon, then how many moles of carbon you have?
Uh, one 1 mole of carbon is 12.
Yeah,
So 3 grams of carbon would be 12, or 3 divided by 12.
that is right. Because you can think logically also, na? 3 grams of carbon has to be less than 1 mole, na?
Yeah.
So it is in the formula form, it is always given mass by atomic mass.
Okay.
So this is 1/4 mole. And if you find out the answer in decimal, then
Sorry?
in decimal, what will be the answer? 1/4
Point
fraction, na? It is the fraction.
0.25.
0.25. Always try to do 0.25, because when
Okay.
you start doing the subjective paper, and initially you will write down 0.25, but after some time that point will disappear and you will be
Okay.
just left with 25.
Okay.
So always make it a habit of writing down 0.25.
Okay.
If you have 6 into 10 raised to power 21 carbon atoms, then how many moles of carbon?
1.
That was 6 into 10 raised to power 23, but
23.
now
Okay.
it is 21.
Um, it's 6 into 10 to the power of 21 divided by 6 into 10 to the power of 23.
That is right. Because if you had these many atoms, it would have been 1 mole. But now you
Yeah.
have 6 into 10 raised to power 21 atoms only, na? So in
Yeah.
formula form, it becomes given number of atoms divided by Avogadro's number of atoms.
Okay.
So what is the answer?
Um, 10
Hmm.
to the power of minus 2.
That is right. Very good. So this is the answer. Or you can put 0.01 also, na? Actually,
Yeah.
options will be given, multiple
Okay.
choice questions. So when it is given in terms of 10 raised to the power minus 2, 10 raised to the power minus 3, then you can leave at this step only. But if you are getting the options to be 0.1, 0.01, 1, or 0.001, so for this question, the answer will be this.
Yeah.
So you just have to see the options given to you.
Okay.
So this was about moles and elements. Then we come to moles and compounds. So what's the definition of a compound?
It's when 2 elements combine together.
Yes, 2 or more atoms of different elements. This is very, very important that different elements should be there, na? Because
Okay.
if you have atoms of the same element, then still you will have element only. You know,
Yeah.
if you take elements, elements have atoms of same kind,
Uh-huh.
atoms of same type. Like if you take under elements, helium, neon, argon, they are monoatomic elements. Mono means single atom, na?
Yes.
Monoatomic elements. If you take oxygen, hydrogen, chlorine, nitrogen, they are diatomic elements, but still they are elements. How can you justify these are elements? Because they act,
Because there's
huh, huh, atoms.
because they come from the same type.
Yeah. P4 is an element. S8 is an element. You know, sulfur contains 8 atoms. 8 atoms. And this has a very, very interesting structure of crown-like structure. Na?
Yeah.
All these corners will be sulfurs.
Okay.
S8 structure. In spite of having 8 atoms, it is still an element.
Okay.
2 or more atoms or different elements combine in a fixed ratio. There will always be chemical reaction. Na? So this is also important. There is not physical present, but chemically combined in a fixed ratio. Third point is this only also, that they also have fixed composition. Like water is a compound. Always the composition is fixed, H2O. CO2. Yeah, all both these compounds will have three atoms in a molecule. Na? One molecule has three atoms, two hydrogen atoms, one oxygen. CO2 has also three atoms only. If you take glucose, then one molecule has how many atoms?
Like, sorry.
One molecule of glucose has
Mm-hmm.
how many atoms?
Uh, it has 24.
24 atoms. And there will be chemical combination. Na?
Yeah.
Like if I give you iron fillings plus sulfur powder in cold, I am not heating it. I just take this on a piece of paper, iron small pieces, sulfur
Yeah.
powder, then
Mm-hmm.
I will get a mixture.
Yeah.
And
But
you can easily separate again the mixture back into the constituents. How do
uh-huh.
you do that?
You can use magnet.
Yes, you can use a magnet. But if you take this mixture in a china dish, in a crucible, and you heat it,
Okay.
so on heating, you will get a
Compound.
compound because there will be chemical reaction, and that
Okay.
formula will be iron 2 sulfide.
Okay.
This becomes a compound, and now it is not possible to reverse back this. A compound
Mhm.
cannot be converted back into the constituents, and the properties will entirely change. In a mixture, both the components will retaining their properties.
Mhm.
In a compound, Fe is no longer Fe, it is Fe2 plus.
Yeah.
It will not be magnetic.
Okay.
Sulfur has gone into S2 minus. So completely it will have lost its properties. Like elements had atomic masses, compounds will have molar masses.
Okay.
So molar mass is sum of the atomic masses of various elements present in the molecule. You will have to add the atomic masses, right?
Okay. Yeah.
We will try to find out the molar mass of water, of carbon dioxide. You know how much of CO2 is there in the atmosphere? In air,
Um. It's almost 92%.
carbon dioxide in the atmosphere.
Oh, no, sorry, that's nitrogen, right?
Uh,
Carbon,
Nitrogen
that's
is 79%.
okay.
Almost 21% is oxygen, and CO2 is just 0.03%. And by
Okay.
human activities, now carbon dioxide has increased to almost 0.04%.
Okay.
Almost. So
Okay.
that is why there is so much of global warming because
Mm-hmm.
too much of CO2. CO2 is not a poisonous gas, but it is a greenhouse gas which is causing so much of global warming. That is why the temperatures are going higher and higher.
Okay.
This year there was no winters in Delhi also, no winters.
Yeah.
And everywhere in US also, there was
Mm-hmm.
much lesser snowfall in Chicago, and so every place is becoming warmer.
Yeah.
Your place also, I think temperatures are going very high in Dallas and Texas.
Yeah.
Okay, so that is because of our activities only, na?
Yeah.
Glaciers are melting. Glaciers are melting.
Yeah.
Find out the molar mass of water. I am writing down the atomic masses.
Okay.
First is water.
H2 is 18.
Yeah. So if you take 18 units, that will be the mass of single water molecule.
Yeah.
Single.
Mm-hmm.
But if you take 18 grams, that will be the mass of, yes, tell me, mass of one mole,
Uh.
1 mole of water molecules.
Okay.
That means Avogadro's number of molecules will weigh 18 grams. You can
Mm-hmm.
also write down in this way 18 grams per mole.
Okay.
18 grams per mole. It means that 1 mole of water weighs 18 grams.
Okay.
CO2?
Uh. 12. 12. 44.
44. Sulfuric acid.
Um, $24. 6. 64 plus 34. 78.
Again check.
Okay. Plus 2 plus 16. 4. 24. 4, 5, 6. 98.
98. That is right. So that means 1 mole of sulfuric acid will weigh 98 grams.
Mm-hmm.
What glucose?
1 times X. 7. 12. 6. 9. 96. 180.
180. So you can see 1 mole of water is weighing 18 grams, whereas 1 mole of glucose is weighing 180 grams.
180.
So every compound will have different molar mass depending upon the elements present and depending upon the atomic masses of the elements.
Okay.
Right? So if I give you the question that you have 4.9 grams of sulfuric acid, so it is equal to how many moles of sulfuric acid? And the molar mass was 98 grams, na? 98 grams. So if 98 grams, if you have 4.9 grams, then how many moles? It will have how many molecules? It will have how many atoms?
So if one of them, 1 mole has 98, then it's 4.98 divided by 4.9.
So I told you to think logically also, na?
Yeah. 90 is 4.9 divided by 98.
Yes. Because when 98 grams is 1 mole, then 4.9 grams cannot be equal to more than 1, na?
Yeah, it has to be less than.
So what is the answer? Mostly you will get such values that it will be completely a factor. If you see 98 is the complete factor of 49. So calculations will not be that difficult now if it becomes a complete factor.
Yeah. Um, 0.05.
That is right. Very good. It becomes 1 by 20. 1 by 20 is 0.05 moles. This is the first answer. Then you have to find out these many moles would have how many molecules?
one mole is 6.10
Yeah.
to the power of 23.
How?
So
Yes, that's right.
it would be
Hmm.
6.02 times 10 to the power of 23 divided by 0.05.
No, it will not be divided by now. When one mole has these many molecules, therefore
Mm,
0.05 moles would have 0.05 into Na, na?
okay.
Into it will become multiplied
Okay.
by. So 0.05 multiplied by Na, these will be the molecules. And third step is find out the atoms.
Um,
If you take the single molecule, it has how many atoms?
it has 98 atoms.
How many atoms?
98.
98. 98 is the molar mass. I am saying
Okay.
number of atoms. Number of
7.
7. So a single molecule has 7 atoms.
Yeah.
These many molecules would have how many atoms?
Uh, divided by 0.05.
When one molecule has 7 atoms, so these many molecules will have 7 into this number of molecules.
Okay.
Because one molecule has these the number of moles for these molecules for these. But to convert the molecules into atoms, you will just have to multiply by number of atoms in a single molecule.
Okay.
Single molecule has 7 atoms, so these many molecules will have this into 7,
Okay.
right?
Yeah.
So otherwise, if the complete number is there, then write down that number only. Na always stands for that Avogadro's number only, right?
Yeah.
If you have to find out the mass of 2 moles of glucose, find
Okay.
out mass of 2 moles. Molar mass is 180.
Okay. 1
Hmm.
mole is 180.
Yes.
So 2 mole
Hmm.
would be 360.
360. And the units?
360 grams.
That is right. This will be mass of 2 moles of glucose. No problem, na? So
Yeah.
that means if you are given the mass can be converted into moles, and then you can get molecules also, atoms also, everything. If number of molecules are given, then also you can find out moles. Suppose if you are given these many water molecules, then you can convert into moles. How many moles it will be?
Uh, 1, 6 times 10 to the power of 20 divided by Na.
That's right. That is right. So these many moles.
Yeah.
So this is 10 raised to power negative 3 moles, na?
Yeah.
And if you have to convert these moles into grams, then what will you do? Moles into mass, then what will you do?
I have to convert them into atoms.
No, mass. I'm saying
Oh.
you have to convert these many moles into mass.
Then I multiply it by 44.
18, it is water, na?
Oh, sorry, what? Yeah, 18.
You're right. You will multiply by 18. So 0.018 grams. No problem. So that means the most important thing is you just read the question carefully and then just go step by step. You will
Okay.
never make a mistake.
Okay.
Then we have moles and gases also. In gases, we always measure the volume. But for the volume of a gas, we have to specify the conditions regarding the
Okay.
temperature and pressure. Because when you change the temperature or pressure, the mass doesn't change. but the volume will change. So volume is always directly proportional to temperature. This sign is proportionality sign, it is called. If you put this sign, it stands for right hand side.
Proportion.
It is for infinity.
Okay.
But if you put this sign, it is for proportionality. So that means more the temperature, more is the volume. And whenever you put capital T, it is always in Kelvin scale.
Okay.
Have you heard about this Kelvin scale?
Uh.
Standard unit of temperature. Actually, standard international unit of temperature is Kelvin.
Okay.
And volume is inversely proportional to pressure. So what do you mean by inversely proportional? More the pressure, less is the volume. Less the pressure, more is the volume. Right?
Okay. Yeah.
And what is this SI unit of temperature? Kelvin. The lowest possible temperature in degrees Celsius is minus 273.15 degrees C. This is also called absolute zero. Zero Kelvin.
Okay.
So if you take 0 degrees C, it becomes approximately 273 Kelvin. If you take minus 100 degrees C, just to convert Celsius into Kelvin, you add 273.
Okay. Then I add 273 to 100. So
Add
I'll get 172. 173.
Kelvin, that is right. So usefulness of this scale is all the negative temperatures can be converted into the positive values. No?
Yeah.
And we have that relation also to convert centigrade into Fahrenheit. Like you are taking the temperature in Fahrenheit in US, na? And we take in Celsius.
Yeah.
In this expression, you can interconvert centigrade and Fahrenheit.
Okay.
So we for these gases, we have 1 mole of any gas at STP. STP stands for standard temperature and pressure, which is 0 degrees C and 1 atmosphere pressure.
Okay.
Always occupies a volume of 22.4 liters.
Okay. Ma'am?
Oh, yes. So 22.4 liters it is, na? Okay?
Yeah.
So if you change the conditions, the volume will change accordingly, which you can find out from ideal gas equation.